let's continue on here. Finding out what is our GCF and taking that out. So for D here, GCF. Okay, well, the smallest x squared x, none would be none. The smallest y squared y, no y, so it would also be no y's. So the smallest, there's no letters. Now, I'm pretty sure they could all be divided by 6. However, because the first one starts with a negative, we have to take out a negative. So the GCF here will be -6. So just remember that rule, common practice, is to take out a negative if the first one is a negative. So we'll take out a negative and then a 6. So -6 will be our GCF. -6 over -6 is 1, and then we're left with an x squared. 60 over -6 is -10, and we're left with an x and y. And -150 over 6. So if you want to just do that, you can do it off to the side here. You can go, okay, 6 into 150. 6 goes into 1 no times, but it does go into 15 twice. 2 times 6 is 12, which gives you a 3, and you can carry down this 0. 6 goes into 30 5 times exactly. So -150 divided by -6 is a positive 25, and there's a y squared left over. So we now need to factor that. Of course, this thing is moving around a lot. So the left side, x times x, needs to multiply to the left, which is an x squared. The right side needs to multiply to 25. Which I know is 5 and 5 or 1 and 25, and chances are it's a 5 and 5. So this diagonal is a 5x, this diagonal is a 5x for a 10x, but we need -10. Actually, I forgot here, I need to have a y and a y. That way 5y times 5y is 25y squared. So this diagonal is a 5, this diagonal is a 5, which we get you 10, but I need negative. So I'll switch the signs to a -5 and a -5. Now that still does preserve. -5 times -5 is 25, so we're still good there. And my diagonals are going to be a -5, so x times -5y is going to be -5xy, and x times -5y is -5xy as well. And if you add those, you get a -10xy, which is my middle term. So factor that correctly, x minus 5y, x minus 5y. So you have an x minus 5y, but you have 2 of them. So I'm going to write x minus 5y squared, because I've got 2 of them. And then I've got that -6 that I had to bring down in front as well. So that is my answer. Let's continue on here. Okay, so with this one, I know that because the first thing here starts with a negative, before anything else, I know I'm going to divide a negative out. Now for letters, x squared x, no x, so no x's are the smallest. And then for the y's, y squared y, no y, so I guess no y's are the smallest. And then what number can come out? I thought maybe it would be an 8, because these can be divided by 8. But 56 would be 8, or 48 would be 8, but I can't do 50. So then I thought it was 4, because 32 can be divided by 4, and 80 can be divided by 4, but 50 can't. That would be 12.5. So it has to be 2. So you can always try 2, by the way, and if you can take more out, then we can just change that. So a -2 will come out in front. The -32 divided by 2 is going to be, -2 is going to be positive 16 with an x squared. 80 divided by -2 would be -40 xy. And -50 divided by -2 is a positive 25 y squared. Now one thing I do notice is that 16 and 25, my two end numbers, are perfect numbers. So 4, 4, 5, 5. So I'm going to start with those and just try it. 4, 4. I need an x and an x. That way I get my 16x squared. And then 5y and 5y, which would get me multiplied 25y squared. Now my diagonals are going to be, if I look at just the numbers here, that's going to be a 20. And 4 times 5 is another 20. 20 plus 20 is 40, but I need -40. So I can change both of the symbols. So this diagonal here would be a negative 20 xy, and 4 times negative 5 is another negative 20 xy. If I add those together, that's of course negative 40 xy. So we have a 4x minus 5y and a 4x minus 5y. So I've got two of them. 4x minus 5y squared, and there's a negative 2 that I was able to take the GCF out of. This is now considered fully factored. Ooh, I don't like that. All right, let's try the next one. Okay. Well, I know I can take a 10 out. I think that's all I can do, actually, is take out a 10. So the GCF of this thing will be a 10, not negative. And then y's, y2, y2, y2. So y2, how about x's? x3, x2, and x, the smallest is an x. So 10xy squared. That'll be my GCF. 10xy squared, 10xy squared, 10xy squared. So I take that out, I factor out a 10xy squared, and what am I left with? 40 over 10 is going to be 4. 3 x's, and there's 1 x on the bottom, that leaves 2 on top, and both of my y's are gone. 120 over 10 is 12. There's 2 x's on top and 1 on bottom, that leaves me with just 1. And of course the y squareds are gone, plus 9, 90 over 10 is 9. There's 2 x's, 1 on top, 1 on bottom, those will cancel, and y squared will also cancel. And it looks to me like, okay, 4, that's a perfect number, 2 and 2. 9 is a perfect number, 3 and 3, so I'm just going to start with those. So 2 and 2, of course I need the x, and 3 and 3. Now this might not work, but it's a good place to start. So that diagonal will be a 6x, and this diagonal will also be a 6x, and if you add them, you get a 12x, which is exactly what I needed. And so these are the same, 2x plus 3 and a 2x plus 3, so that's a 2x plus 3 all squared. And of course I need that 10xy squared that's out in front. Okay, so that is F, and I will go on to the next one. Okay, I need to take something out of this. Oh, we did take 6 out of 150 previously, and I think I got 25. Yeah, 6 into 150, 25. Okay, that's good to know. So first thing I notice is that there's a 6 in common that I can take out, which would leave me with an x squared minus 25. The other thing I notice is that the middle term is gone. I got the x squared, I got the number, it's the x, the middle one, that I'm just missing. So it must have been a 6x squared plus a 0x minus 150. That's what it was, and of course we didn't write the 0 because 0 times anything is just gone. So I need to make sure my diagonals cancel out. I also notice that 25 is a perfect number, and that it's like a 1 out in front. So 1's a perfect number, 25 is a perfect number, there's a minus sign in between, the middle term is missing, this is a difference of squares. So if difference of squares, we'll just use the square roots, so 5 and 5, but you make one positive and make one of them negative. And then that usually gets you 0. So x times negative 5 is a negative 5x. X times 5 is a positive 5x. And if you add those together, you get a 0x, which is why it's not written. That's perfect. So x plus 5 and x minus 5. Now don't forget, when you write these, if you took out a number, you got to write it out in front, which is a 6 in this case. So x plus 5, x minus 5 with the 6 out in front. So that's a reminder of difference of squares. Let's try some more. Okay, I got another one here. I know I'm missing the middle term, by the way, because I see an x squared, and the middle is always going to be half of that, which is an x. I see a y squared on the end, and so the middle will be a y. So that's why this is technically missing that middle term, which would have been an xy. So this would have been an 18x squared plus 0xy minus 128y squared. So that's what that would have been, and of course we didn't write the 0. Now 18 is not perfect, 128 is not perfect, but I have to think, oh, there is something I can take out of all of these, which is just a 2. Which is going to be, if I take the 2 out, it's going to be a 9, perfect number, and 128 cut in half is 64, perfect number. So that's easy enough now. I've got a perfect 9, a perfect 64, there's a minus sign in between. I've only got 2 terms. The x squared can be x and x, the y squared can be half to y and y. So we're good. Just everything's got to be the same, and then make sure one of them is negative. And then we can double check. 3 times negative 8 is going to be a negative 24. There's an x and a y. And 3 times 8 is going to be a positive 24. There's an x and a y. And if you were to add those together, you get 0 xy's. So that is exactly what I needed. So I'll have 3x plus 8y and 3x minus 8y with the 2 out in front. So 2, 3x plus 8y, and then 3x minus 8y. Okay. And what do we have? Okay, it looks like the last one here. So again, the thing I notice immediately, it's missing a term, probably the middle term, because we've never missed anything else. It's always been if there's 2 terms, that means the middle term is missing. However, 32 is not a perfect number, neither is 162. Also, 3 can't be broken down to 2 numbers that are the same. It's like 1.5 and 1.5, so that's kind of weird. But we do know that we can cut things. Well, if I take 32 and cut it in half, I do get 16. And if I cut this in half, I should get 81. Okay, so let's cut these in half. 81 is perfect, and so is 16. And this has x3, this has x1, so they both have an x. So the smallest between x3 and x is just going to be an x, and the smallest y is a y2 and no y, so no y to be the smallest. So I have a 2x. Like I said, 162 divided by 2 is 81. There's 3 x's on top, 1 on bottom. We're leaving a remainder of 2 on top. And 32 over 2 is 16. 1x on top, 1x on bottom will cancel, and there's just a y squared left over on top with none of those on the bottom. And now I see, okay, 81 is perfect, 16 is perfect, x squared can be broken down to x1 and 1, y squared is y1 and 1, the middle term is missing. So this is clearly a difference of squares. So I will try this here. I'll do 9x, 9x, 4y, and make one of them negative. And double check, so this is going to be a negative 9 times 4 is 36 with an xy. 9 times 4 is a positive 36 xy. And if I add those, yep, you do get a 0 xy, which is the middle term. It's missing. That's why it's 0. Now, I'll write this down here. 2x, and then I got a 9x plus 4y, and 9x minus 4y. I do notice here, well, 9's a perfect, 4 is perfect, there's a minus sign in the middle, there's a middle term that's missing. Isn't this factorable again? 3, 3, 2, 2. The problem is it's not an x squared. It needs to be an x squared so we can do x and x, or an x4 so we can do x2, x2. But how do you make that? Like, you have to make them both the same, so you kind of have to do x a half, and that looks kind of weird to get to an x to the 1. So because it's not squared, we can't factor it any further like this. So we will just leave our answer as it is. You do want to be keeping out an eye for a double factoring question, but one of these would have to have at least an x squared and a y squared. In there. The letters have to be able to be cut in half. And the numbers obviously need to be perfect, which they are, and the minus sign needs to be there. So close to a double factoring question, but not quite.